You'll learn about model-driven programmability with Yang, NETCONF, RESTCONF, and gRPC. So a data model is a well understood and agreed upon method to describe something. You can also see this being described as a schema as well. So it's a way that data is laid out and organized. In the example here, you can see how a car dealership would maybe have their database laid out. So the data model for that. You can see here at the top level, we've got the make, which includes the ID for the make, which is an integer, meaning it's a number, and the name, which is variable length characters up to 45 characters. We've also got the model of car with the model ID, which is an integer again, then the make ID, and also the name for the model. And we've got the trim or specifications of the car, which has got the trim ID, the model ID, the name, and the year. So a data model is just a recognized and agreed upon way that your data is going to be laid out and organized. Yang stands for yet another next generation. It was standardized by the IETF in 2010. It's a data modeling language which provides a standardized way to represent the operational and configuration data of a network device. So for using remote devices to interact with our network devices, to be able to pull information from them and to push information from them, the client, which is the API, which is working with the network device, and the server, which is the network device itself, they need to have a standardized format for that data to be laid out in, and Yang is commonly used for that. It's an open standard, so it's used by different network device vendors. It can be used both internally on the device as a way of describing all its components and features, and also when packaged for transmission, for example, when interacting with an API. So looking at the Yang format, at the top, we've got the module name. And you can see here, this is a standard IETF module, which describes the network devices interfaces. Then we've got a couple of containers under there. The first container describing the interfaces, it includes information like the name, the description, the type, whether it's enabled or not. And then we've got another container for the state of the interface, which includes information like the name again, the type, the admin and operational status, etc. So that is how the Yang format is laid out. The configuration and operational status of a network device's components and services can be remotely read or written too. NETCONF, RESTCONF, and gRPC are APIs which describe the protocols and methods for transport of that network management data. So looking at the model-driven programmability stack, on our network device, we've got things like its interfaces, also its features like BGP, QoS, etc. And then we've got the modules there, which can be standard, such as the IETF interfaces that you just saw. There can also be vendor-specific modules as well, because maybe you've got a particular network device which has got features on there that are specific to that device. Well, in that case, the vendor would have a vendor-specific module. And they're going to be laid out into modules which describe the configuration and also the operational status as well. So we've got our Yang data models that resides on the device. And if we want to interact with that information, so if we're using an API to pull the information to read it, or maybe we want to push information to that particular device, then we can use NETCONF, RESTCONF, or gRPC to do that. So NETCONF, RESTCONF, and gRPC, those are our transports that we can use to interact with the Yang data. So looking at our NETCONF communications, we've got the Yang data that is encapsulated in XML, and then we've got the NETCONF information, which is further encapsulating that. And we can send and request information to the server, which is going to be our network device. So NetConf was designed as a replacement for SNMP. The issues with SNMP is there's security concerns there, particularly if it's before SNMP version 3. And SNMP is good for reading information. It's not so good for pushing information to the devices. So Network was designed as a replacement, really as an upgrade for SNMP. NetConf and Yang provide a standardized way to programmatically inspect and modify the configuration of a network device. So Yang was standardized in 2010. It's a data modeling language which provides a standardized way to represent the operational and configuration data of a network device, as you learned earlier. NetConf was standardized by the IETF in 2006, and it's a protocol that remotely reads or applies changes to the data on the device. So that might seem like it's the wrong way around, where Yang actually came out after NetConf, but that's what happened. So the way to work with the data was actually designed first. So NetConf wasn't really used back in 2006. It wasn't really usable until Yang came out in 2010. And Yang was actually originally designed to work with NetConf. With NetConf, it's mandated that XML coding has to be used, and the transport is usually over SSH. It can also run over TLS as well. So looking at the NetConf protocol stack, we've got the content, which is the data to be inspected or changed. Operations, for example, getting the config or editing the config. This is initiated by RPC methods using XML encoding. Messages do use RPC, that stands for Remote Procedure Call. RPC simply means it allows one system to request another system to execute code. And we've got the transport between the client and server, as I said earlier, supports SSH or TLS. So looking at the protocol stack with NetConf, we've got the transport, SSH, TLS is also supported. The messages are using RPC. We've got the operations, which is the action to perform. This is the CRUD action that we're going to be performing. And then we've got the actual content. We've got the body there as well. Okay, moving on, we've also got RESTCONF. RESTCONF came out later in 2017, and it builds on NetConf. It's also an IETF draft. It describes how to map a Yang specification, but here to a RESTful interface. It uses HTTP verbs over a REST API, and RESTCONF is not intended to replace NetConf. So it doesn't have quite as much functionality as NetConf, but it is simpler to use, and everything REST-based nowadays is very popular. With our NetConf, it was mandated that it always uses XML encoding. RESTCONF can use XML or JSON. JSON is seen as easier to read and simpler to work with. And the transport is HTTP or HTTPS. So looking at the RESTCONF protocol stack, we've got the transport is HTTP or HTTPS. We've got our actions to perform. That's our CRUD operations. And it's HTTP based. So it's get, post, put, patch, and delete. And the content is going to be XML or JSON. And looking back at that slide I showed you for NetConf earlier, so if this was RESTCONF that we were using now, it would be Yang data encapsulated in XML or JSON, and then the RESTCONF. Okay, so moving on from there, we've also got gRPC. This is Google RPC. That's an open source remote procedure call system initially developed at Google in 2015. It's well suited to collecting telemetry statistics. So if you're in an Internet of Things environment, you've got a lot of devices and you want to collect a lot of telemetry information from them, then gRPC can be a good choice. GPB, Google Protocol Buffers encoding is used rather than XML or JSON, and the transport is HTTP too. So for interacting with network devices, if you're going to use these, it's going to be most likely NetConf or RESTCONF, but gRPC is also available. Okay, last thing to talk about here is Postman. Postman is a super popular tool to test the operation of REST APIs. So it tests REST APIs, RESTCONF is also testable with Postman because it's based on the same protocols. Postman can be downloaded as a standalone application, or it can be run as a Chrome plugin. With Postman, there's a lot of features and functionality in here. In Postman, your collections and environment variables allow you to easily reuse requests, so it makes it very convenient to work with. Requests can be exported as code in multiple programming languages. So you can send your requests with Postman to test that they're working. You check that they are working as you desired. Directly from Postman, you can export that into code, which you can use in your scripts. Again, very convenient. As well as Postman, you could alternatively use curl in Linux or the request module in Python to test APIs. But Postman, because it uses a GUI and it's got a lot of added functionality, is the most popular choice. And I'll show you how to use it in the next lecture.